Assalamu alaikum wa rahmatullahi wa barakatuhu. Friends, welcome back to my channel. I have this 5 volt 2 ampere charger for mobile phones. It is a very simple circuit. Few components are here. We will draw its circuit diagram and we will see how to follow this circuit. This is AC input terminal neutral line, and here is RF1 fusible resistor that is connected between this point and here. Line 10 ohm resistor, fusible resistor. Neutral is reaching here directly to bridge rectifier. BD1. Number of this bridge rectifier is MB10F. MB10F. This is positive output terminal and this is negative. It is reaching to this capacitor. That is the first one, 400 volt 4.7 microfarad. 4.7 400 volt. Between these 2 points there is this component. It is L1 inductor, brown, black, red, silver, 1 millihenry coil. In negative side, this black component, it is looking like a resistor. I will make a jumper resistor as a fuse resistor, but I think it is inductor. The component ID is R. Then it is connected to this capacitor, that is the second stage capacitor. It is also 4.7 microfarad, 400 volt. Then this positive voltage are reaching to this point. It is transformer primary winding. At the same point there is 200K resistor. At this node, this center point, there is another component, that is this diode, FR107. 204 diode, there is 220 ohm resistor R3, that is this resistor, and then there is a capacitor that is connected to this point and positive terminal. At this node, this point, there is a capacitor CY1 class Y capacitor that is connected between high side and low side, but here it is not connected. Then 1.5 mega ohm, 1.5 mega ohm, 2 resistor in series at positive terminal. One resistor, second resistor, 1.5 mega, 1.5 mega. This winding is connected to positive side, and this winding end, that is this end, it is connected to pin number 5, 6 and this diode, that is this one. Here is MD1801 IC. MD1801 IC. Manufacturer is mixed design. Pin number 5, 6. It is HV pin or drain pin. And if you check this pin number 4, there is a resistor 1.5 ohm resistor, pin number 4. Second side of this resistor is connected to this capacitor. So it is 1.5 ohm, 1R5. It is current sense pin. This is source pin of the output MOSFET. If there is BJT, it is emitter, it is collector. This is drive section. Now if we check this 1.5 mega ohm, 1.5 mega ohm, 2 resistors connected in series, and these are reaching here at this point, and these are reaching to pin number 1. This pin number 1 is VCC. At pin number 1, there is this capacitor, this one. 10 microfarad 50 volt. In parallel to this capacitor there is another capacitor, ceramic capacitor, that is for ripple removing. It is VCC capacitor. When the circuit is off, this resistor network will charge this capacitor and then this IC will start. Pin number 8 is connected to ground from the bottom side of this IC at this pin. Pin number 8 connected to ground, that is this ground. This is winding end. It is also connected to ground. This point, winding end, it is also reaching to this ground point. And winding second end, that is this one. So this is auxiliary winding. I will draw part of this winding here. This end is connected to capacitor ground, that is hot side ground. Then this diode RS1M, it is connected to this VCC capacitor. From the same point there is R8 6801 6800 ohms. This end is connected to these two resistors 5101 4702. Second side of this resistor is connected at the same point, and these are connected to this capacitor ground. One resistor is 470 and 2 zeros 4702, and this one is 5101 47000 multiply with 5.00 divide by 4730 plus 5100. RT is equal to 4600.7 ohm. So two resistors, high value and low value resistor, these two resistors are equal to 4600 ohms or 4.6k resistor. And these two resistors are connected to pin number 2. Pin number 2 is feedback pin. At pin number 3 there is capacitor, that is CPC, compensation pin. So these components are in primary side. In secondary side, this is winding, one end, second end. And here is diode SS24, that is Schottky rectifier. At these 2 points there is capacitor, 10 volt 680 microfarad, 10 volt 680 microfarad. In parallel to that capacitor, this end and this end, there is dummy load resistor 1K. And these are two output terminals, positive, negative. So this is the circuit. This time I am not opening transformer. In upcoming session we will disassemble transformer and we will see turn count of these windings, line and neutral. Fuse resistor, and it will reach to bridge rectifier. It will convert that AC voltage into DC voltage. Smoothing capacitor, this one will hold that DC level. Then there is inductor here and here. These will reduce EMI because it is not fixed frequency oscillator. It is variable frequency depending on the load. It will sense the feedback from this network. It is not using optocoupler or TL431. It will check what is the voltage being induced during rectification time. This end is ground. This ground is reached at pin number 8 as a chip ground. This IC is not switching until now. These resistors, these are called startup resistors. These will provide voltage, charging current to this capacitor. When voltage level will start to build up after obtaining a specific threshold. That time this IC will start switching. When it will switch, it will allow current from this negative terminal, pin number 4 to pin number 5, 6 in this winding. Here are positive voltage, 310 volt in case of 220 volt AC. It will start switching. Energy will start to store in the transformer core. So in off time, that energy will be transferred in the output side. Same time, in the off period, this winding will also receive voltage because it is flyback converter. When it will receive voltage, it will provide rectified voltage to VCC pin. So this IC will start functioning in normal working condition. At that time, it will sense the load from this resistor network. If there is no load, there will not high rectification current in this winding. That time, in this winding, the voltage level will low. So it will become to know that there is light load. It will adjust its frequency for minimum switching. If you will connect any device here, that will draw current from this capacitor. This capacitor will become empty. When it will become empty and load is connected, it will charge this capacitor and the load. In result, more current will flow here. That more current will cause to increase voltage here. That voltage level will define the load size because the pulse level here will also increase. So feedback pin will become to know that there is a load. When there is load, it will increase its switching frequency to store more magnetic field, and it will transfer voltage rapidly to maintain the voltage in this line. Meantime, it will also measure the current. How much current is flowing in this channel, this resistor, 1.5 ohm. Current will flow for transformer from its power switching device, that is BJT or MOSFET. How much voltage level is dropped here due to this resistor, it will measure that voltage. So it will become to know either it is working in CV, constant voltage mode, or in CC mode, constant current mode. We stored energy. That stored energy is being transferred in this side, but due to load, this current will add in this magnetic field, and here voltage level will increase. That increased voltage will give feedback to this IC. One feedback from this side, second feedback from this side. Both values will reach to this IC. This IC will know what is the load size and what is the current value. If this current value is within range, that time it will work in constant voltage mode. So it will adjust its frequency. In upcoming session, we will connect oscilloscope to check its function. We will apply loads and we will see different pulses. We will monitor the current pulses. We will monitor the feedback pulses, and we will check the switching pulses. If you think this video is informative, give a thumb up. If you have any question, please write in the comments. Thanks for watching. Assalamu alaikum wa rahmatullahi wa barakatuh.